All right, so far this semester, we've been looking at creating our, what we would call business logic classes. And problem domain classes is probably a better word for that. In other words, the problem that we're trying to solve, we create our classes. So for example, we created our student class, we created a course class, we created a graduate student class, and probably some other classes in there. For the magazine one, we created the different subscription classes and all that. Now, if we were on a project, on a large project, it might involve a lot of people working on a lot of classes. And you want to do your job, and you want to make sure that your work does what it's supposed to, that it works. So therefore, you create your classes I'm going to say business classes, and you want to test them to make sure that they work out okay. So that was the purpose of us writing that unit test class. I know some of you might see that and think, well, you're not supposed to hard code in code. That's true. You would never hard code over here in the business classes. But this unit test class is just something that you're putting together to make sure you did things right. You may look at your code and swear, yeah, this is going to work, but there's been, literally thousands of times in my career that I swore I had code that worked, that when it was tested, there was a problem with it. So don't assume anything works until you've tested and you've proved it. And that gets to be a complicated business, right? Because you have to, you have to try to encounter as many possibilities as you can in these classes. Now, once it's past that, it's going to be put in with everyone else's classes. And you might create an application. And that application will likely have one or many GUIs associated with it. Because when you write these classes, and again, I have commented on this on some of the assignments that people have turned in. Keep in mind, when you're defining a class, you're defining sort of a representation of a particular entity that you can plug anywhere into your system. So in other words, doing a tuition calculation, that's one thing that you might do with a student. But that same class would be used to do other things that students do. And there would be other enhancements made to it. And there'd be methods added and attributes added and so on. So that's liable to get access through different GUIs. Think again of the different things that a student could do. Students get assigned grades. Students register for classes. Students can drop classes. Students can apply for graduation. Students can graduate. Students can apply for financial aid. Each one of these may have their own GUI that accesses your classes and these other classes too. Shouldn't be a line between the GUIs. Should be a line to the other classes. So what that means is you want to keep your code written so that it's as versatile as possible and as reusable as possible. So for example, this is a small example. If you would write a code that included tuition, which we've done in this class for a student, you'd return that as a double as opposed to a string. Now you could calculate tuition to return a string that said the student's tuition is $358. The problem is you couldn't do that and do mathematical operations on it. All right. So the best thing to do would be to return the numerical value, 358, and then each of these GUIs can decide how to display it. Because each of these might be using the data in a different way. And therefore, its requirements are different, and therefore, the way it might display the data might be different. So our first step is going to be very modest. We're going to just look at Java Swing and AWT classes. It's a very basic form of Java GUI, and we're going to see what goes on. And there's more extensive stuff that we won't get into in this class with Java FX. And if you take the University of Akron program, in the Java 2 class, we studied Java FX. Anyhow, let's look at our first GUI. Our first GUI is real simple. Our first GUI is so simple that it doesn't even have any of these business classes attached to it. All the code is in the GUI. Now keep in mind, I'm keeping it real simple because this is our first GUI assignment. You will not have this in any of the other assignments you do. For example, in your first assignment, you're going to have a GUI to add pizzas to an order. All right. Therefore, you will use the pizza and the order classes that have already been written as examples in this class. And you'll just link your GUI to them. We'll talk more about that towards the end of the course. Or not the end of the course, end of today's lecture. All right. I've compiled my code. There's only one class in here. And it's called First GUI, and there's a First GUI Java and a First GUI class. Let's run it. We'll check out the behavior and we'll see what's needed to do to accomplish this. This is a very simple window that allows us to put in the temperature in centigrade and convert it into Fahrenheit. So I can put in 0 degrees centigrade, and that equates to 32 degrees Fahrenheit. I can put in 100 centigrade, and that equates to 212 degrees. The temperature of 12 degrees centigrade is 53 degrees Fahrenheit. Notice if I type in something that's non-numeric here, you get an error message saying invalid input. All right. We talked about, not in person, but we had a lecture on exceptions. And this is where we're going to use those exceptions a lot, because if invalid data is entered, we're going to go in, we're going to take that and display it on the GUI. So let's look at the code that accomplishes this. All right, first of all, a couple of things that you might notice. We've imported these things. We've imported JavaX Swing. And Swing are the library. Swing is a Java library that includes things that we can use for a GUI, as is AWT. Now, we talked about interfaces a couple lectures ago. Notice that this extends JFrame, and JFrame is a Java Swing component that represents a window, essentially. And it implements Action Listener interface. So what does it mean to implement an interface? To implement an interface, it means that you have to define all the functions that are defined in the interface. So let's Google Action Listener interface. And we'll notice that there is one method in here that is action performed. All right. And therefore, anything that implements that interface has to have an action performed function. And sure enough, if we look here down at the end, we have that action performed function. And it gets passed an action event, which is, again, part of the signature of the function. So we're okay then. We can truly say that this implements that interface. Now, what is an action listener? GUI programs, you're not really sure what order the user is going to do things. All right. Now, in this one, it's pretty obvious the order that the user is going to do things. They're going to enter in data, and then they're going to click on the calculate button. But if you had an interface with a bunch of buttons and drop downs and text fields and a whole bunch of stuff on it, you're not going to know for sure what sequence the user is going to do those things. So your program has to be waiting for anything to happen. All right. And when I say that, I mean your program has to be listening for certain events. And certain events are relevant and certain events are not relevant. And for the events that are relevant, you have what's called an action listener. All right. And the action listener is code that gets called when some event happens. Now, we've defined this class first GUI as extending JFrame and implementing the action listener interface. All right. Any event that we want to have some code where we do something. Now notice when you look at this, notice that we only have an action listener for the button. That's the only place where I need to write any code. I'm not writing any code when the user types something in initially. I'm waiting until the user clicks the button. So let's look at what we have. First of all, these are the graphical things on the frame. There's a label for temperature, text field, which is different than a label because you can enter values into a text field. You can't enter values into a label. We have a button, a J button. Its title is convert. And we have a label that initially is empty, but is going to hold the results. So in other words, when this runs, we see these four things: label, temp, text box to enter the temp, the button to convert, the label on the button is convert. This label says enter temperature in centigrade, so that's why we see it there. And we have results. Well, when we first started off, we don't have any results, right? So it's initialized to an empty string. Okay. So those things don't automatically get added to the frame though. We have to manually add them onto the frame. And we'll see how to do that a minute ago. All right. We have a main method on here, which simply creates an instance of this class. And when we create an instance of the class, what runs? The constructor runs. So if we execute the main method on this class, we're going to call this constructor, because that's the only constructor that this class has. We're going to set it to be visible. We're going to set the default close operation to exit. That's why, if you notice, if you look closely, when we run this, notice this running. Notice we're not on the next line on the command line yet. When we close it, boom, that finishes the program. So that's what these things do. They make it visible, they make the frame visible, and they set the operation to close. Next thing we're doing is we're creating a panel. Think of a panel as sort of like a section of a GUI, right? And this is a very simple GUI, so we just have one panel. Let's think of a different case, in a bigger case with a bigger GUI. We might have personal info with name, mail. We might then have employment information. That has your employer, when hired. Each of these could be a panel. So a panel is a section of a frame. All right. In our case, we're only having the one panel, so things are simple. We only have those 4 things that we're putting on the string or on the frame, on the screen, and therefore life is pretty easy for us. So hold your thought on this one for a second. We're adding each of those things to that panel. We're adding first the label temp, then we're adding the text field, then the button, and then the results label. By default, when we add something to a panel, it gets oriented horizontally. So that's why when we noticed this, when we ran this program, those 4 things were in a straight horizontal line. Because by default, they're going to be in the order that we add them in and in a straight line. This goes and puts that panel into the frame. Each frame sort of has its main panel, and in our case, that's this panel. And then we set the size of it to 800 wide, 100 high. That's why it was long and not very tall. Here's probably the most interesting part of it, though. Button convert add action listener. What does that mean? All right. And the argument to that function is this. All right. Whenever you see this in programming, what you're referring to is the very object that you are currently looking at. So what this is doing is when we create one of these frames, we're setting the action listener for that button to be that frame object that got created, this object. This first GUI class creates an object, and we're setting the action listener event to this object, that frame that got created. So what does an action listener mean? It means that when something happens, the onActionPerformed method in the action listener is going to get called. So the effect of this line says, when we click on the button, call this function. And it gets past an event object, which we can use to tell different information if we need it. There's nothing really to use it for in this case, so but you have to declare it because that's the argument. So when the button is clicked, we're going to execute this code. So what are we going to do? We're going to create a double to contain the centigrade, a double to contain the Fahrenheit. We're going to get the text from the text field. That's how we get the text from the text field. And we're going to try to convert it to a double. A text field contains text. When we say get text, we are getting back a string. If we want to use that data some other way, like as a date or as a double or as anything else, a Boolean, we have to go in and we have to convert it to that data type. And that's what double.parseDouble means. It means look at this string and try to convert it to a double. Now, notice this is inside a try block. It's inside a try block because if we put a number in here, everything's going to be okay. We'll be able to convert it to a double and we'll store that value in the variable C. If, however, we type in some letters here, this statement is going to throw an exception because you can't turn the word cat into a number. All right. So therefore, it's going to throw an exception and this is going to happen and we're going to report in the result label that there's invalid input. So we created all these. We set the action listener to that code. It's in the frame itself. We enter in the word cat. That parse double doesn't work, throws an exception. We set the results to invalid input. Now that's about the only thing that can go wrong with this frame. All right. It's such a simple numerical conversion that that's about the only thing that could go wrong, is that you don't enter a number into that field. With a more extensive GUI that dealt with other objects and so on, we might test for the specific exception that gets thrown so we can display a more meaningful error message. But in this case, we know about the only thing that could go wrong is that the user doesn't type in a valid double into that field. And therefore, we can say that the error is invalid input. Notice what these things are. Say set text. So we have a get text and we have a set text for the label. Get text for the text field. How do you know all these things? Again, you go to the Java docs. We were looking at the Java docs for action interface before. And it describes the inheritance structure, and most importantly for us, it describes the methods that we have to implement when we implement that interface. Let's look for JText field. And we see, again, it's a swing object. Shows you an example of using it. Shows you the constructors that can be called. And shows you the methods that it has. It's an add action listener. So we could do something anytime the user presses a key. Sometimes you'll see that in an application if you have 500 characters, let's say, for a description or a comment. That as every key that you enter, it will decrement it by 1 and show you that you have 499 left and 498 and so on. It also has methods that were inherited, and among those are getText method. With these libraries, again, keep in mind that when we look at a class, there are more methods available than are listed in the method list because it can inherit some methods from other classes as well. So, assuming we do not get an error, multiply centigrade value times 9 divided by 5 plus 32, and that gives us the value in Fahrenheit. Then we can set the text of the label results to the value of F plus the words degrees Fahrenheit. I'm going to show you some errors that could result if you didn't do this properly. If I don't say that this implements action listener, well, you already know it's going to be a problem. Let's see specifically the problem. It says that first GUI cannot be converted to action listener. What does that mean? Well, we can only set an action listener to be something that implements the action listener interface. And if this object doesn't implement the action listener interface, then we cannot make it that button's action listener. So whatever object we define as being the action listener, it has to implement the action listener interface. If we forget this function, we forget that function, we get an error because we promised that this class implements action listener, and yet we don't have the action perform method defined in this class. Now, if you have a simple case like this, where you have just one button, you can very well make the action listener for that button be frame itself. And then say, I want this object to be the action listener for that button. Any questions on this so far? Now, there's another way that you can do action listeners, and that is by defining separate classes. I'm going to bring this example up just to kind of show you. It does pretty much the same thing, but it's a little more involved as there are two buttons. Now we have two of these. So this is a more involved example. We can enter in a value, then we can either convert centigrade to Fahrenheit or Fahrenheit to centigrade. Now notice that these are not aligned horizontally. Let's see how we did that. Notice also something funny here. We have these classes that include dollar signs, right? Those are our action listeners because we created action listeners a different way in this example. So we have all this. Notice we have first GUI as extending JFrame, but we don't say that it implements action listener. Therefore, what does implement it? This C2, for the first button, from the Fahrenheit to centigrade button, what implements it is a new C to F object. And C to F object is contained inside of this class. This is called an internal object. We're usually not too concerned about implementing these as their own separate standalone objects because typically we're going to use these action listeners in conjunction with a GUI. So we say C to F, that implements action listener. So I can say that there, new C to F object. That's okay to say because that C to F object implements action listener. And then we have the action performed that does essentially the same thing as it did before, except we check to see if it's, well, no, we don't check. We take the centigrade and convert it to Fahrenheit, just like we did in the other case. That corresponds to what we saw here, right here. It doesn't get its own class with its own name. It's part of this because it's called an internal object. It's part of that other class. Second way to do it that's differently is we don't even have to define a class, a new class. We can simply say new action listener. Got to be very careful if you do this because you notice there's all those parentheses and less than and all that. Kind of can be confusing at times. But essentially what this is doing, this is creating a brand new object that implements the action listener interface and has its own action perform method. And that one does the Fahrenheit to centigrade version. I would suggest for your first lab to do like we did in the first example. We'll look at other examples and we'll talk about those. We'll talk about inner classes and anonymous classes a little bit more later on. But I would suggest doing this where you just make your frame, extend. Oh, wrong version. You have your frame, extend JFrame, and implementing action object. Then you can put the action listener or the action performed method right in the frame, and you can say that the action listener for the button or whatever is this. Okay, your assignment is a little more involved in this, so I want to take a little bit of time talking about this assignment. We have our two classes that I use as examples throughout the semester. Order, pizza. You're going to create a GUI that's going to use these two objects, these two classes. All right. For the assignment, you only need to worry about one order. So you don't have to worry about creating a first order, closing it out, creating a second order. You're welcome to do that if you want to, but that's not a requirement. So what are you going to do? You're going to declare up here an order object. And you can supply any of the arguments that this needs. I forget what this constructor consists of. You'll create that up here. These are called instance variables. They're called instance variables because there's one set of these for every instance of this class, for every object. So we're going to make this object's order, right? We only need one order, so we're going to create that up here. So we define our order object at the top as an instance variable. Just one order you need to have. You're then going to have somewhere in here, you're going to have text fields for the sides and different things. But you're going to have somewhere an action performed. Follow my suggestion, it will be part of this frame. And what that will do is that will create a new pizza object. Set the properties. Add the pizza to the order. And get the values from the order. Update the GUI. Now remember, the methods to set the properties are already defined in the pizza object. The method to calculate the cost of a pizza and to calculate the cost of an order is already in the order object and the pizza object. You don't have to write those. You have to, though, call those methods to get the results once you've added that pizza to the order. Now, ideally, you won't use text boxes for everything. Certain things have limited selections. For example, the crust is either thick or thin. In Canvas, we have an example of radio buttons and forms. Let me look at this forms one. See what's in that. If you look at this example, you'll see how to create a drop-down, right? And how to call values from a class. So this high-low game, you get to choose, is it going to be low? In other words, when you roll two dice, is the values of the dice going to be between 2 to 6? Is it going to be 7 or is it going to be high? And you get paid off different amounts depending on what the option is. So I picked high and I rolled a 2 and a 6. That's 8. So 8 to 12 is considered high, so I won that. If I pick 7, you have to roll exactly a 7. If I pick low, 2 to 6 wins. Go over this example on your own. You'll see some good things in it. You'll notice, for example, that I have several panels here. If you notice when we run this, notice how we have a label up here and we have these things horizontally. And when we roll, we put the answers over here. So we actually have 3 panels. A main panel that is stacked vertically, then we have add a text label to it, add these things to a second panel, and add these to another panel. So by creating panels, you can stack things differently than the default of horizontal. And we saw that in this example as well. I created 2 panels. I accidentally delete some code from that. Small example. Oh, I see. This constructor extends longer. All right, I have 2 panels. Panel 2, I add the 2 buttons to. Panel 1, I set the layout to be vertically horizontal oriented. That's what the y-axis means. I add the label for temperature, the text for temperature, and then I add the second panel to the first panel. I add the label results to the first panel, and then I make the content pane for this frame the first panel. So when we look at this, everything is one panel. This is a second panel. And then I just added the text label, the text field, panel that contains the two buttons, and the panel that contains the results. I added that to the main panel. And by doing this and being sure to import the border layout, I'm able to orient that panel vertically. All right. That's all I have for today. We actually do not have class next Monday, and it's not my fault this time. It's Veterans Day Monday. So we will not have class Monday. The campus will be closed. I will post a lecture from last semester again. All right. If there's no questions, that's all I had today.